Hello everyone and welcome to my workshop. Which one is the best flagship SBC in the market right now? I'm going to compare these three Pi 5 SBCs. I'm talking about the Raspberry Pi 5, the Orange Pi 5 Pro, and the Radxa Rock 5C. The Radxa is not technically a Pi, but you know what I mean. I'll be using a similar grading system to my video where I compared the three main zero form factor SBCs. First, I'll take a look at ease of use because we all want to finish projects fast. We finish projects, right? I don't want to waste time with an SBC that doesn't have good software and hardware support. I'll be taking a look at available documentation as well because in my zero board comparison video, Radxa and Orange Pi got low marks on documentation. I wonder if their documentation is any better for their full-size SBCs. Next, I'll be taking a look at performance. The Orange Pi and the Radxa boards have very similar CPUs, so it will be interesting to see if they perform any different. Raspberry Pi 5 has a lesser CPU, but does it make up for less performance in other areas? I guess we'll find out. The third category is feature set and expandability because we expect greatness from these little guys. Just slapping a CPU, some RAM, and GPIO pins on a PCB doesn't cut it anymore. Lastly, we'll take a look at AI capabilities. And yep, we're going to talk about AI because everyone is talking about AI. I should mention that Orange Pi sent me the Pi 5 Pro for free, but I paid for the Raspberry Pi 5 and the Rock 5C with my own money. If Orange Pi hadn't sent me for free, I would have bought it anyway to make this comparison. I think it will be clear throughout the video that I don't favor the Orange Pi just because they sent me this unit for free, but you be the judge of that. Before we start the comparison, let's take a look at some basic specs. Let's start with the golden standards of SBCs, the one and only Raspberry Pi 5. It has a quad-core 64-bit ARM Cortex-A76 CPU clocked at 2.4 GHz, video core GPU that supports both OpenGL and Vulkan. It has built-in 5 GHz Wi-Fi and Bluetooth 5.0 with BLE. It is the only board in this group that doesn't require an external antenna. It has gigabit Ethernet, dual micro HDMI capable 4K60, two USBs 2.0 and two USB 3.0 ports, two MIPI connectors that play double duty as either a camera connector or a display connector. And one of the headlining features of this board, of course, the PCIe expansion connector. The Raspberry Pi 5 retails for $50 for the 2GB version, $60 for the 4 gigs, and $80 for the 8GB version. It's good to mention the Raspberry Pi board doesn't have an option with eMMC storage, which is something that both the Radxa and the Orange Pi have. Let's talk about the other fruit board, the Orange Pi 5 Pro. It has a Rockchip RK3588S, which has 4 cores of ARM Cortex-A76 and 4 cores of ARM Cortex-A55 to make it an 8-core CPU with the main frequency of 2.4 GHz. Although it has 8 cores, 4 of those cores are the slow A55 cores. It has an ARM Mali G610 GPU compatible with OpenGL and Vulkan, just like the Raspberry Pi board. It has an embedded NPU with 6 TOPS of processing power for AI tasks. More on AI later in the video. It has a built-in 5 GHz Wi-Fi and Bluetooth 5.0 with BLE support. It requires an external antenna that comes included in the box though. Gigabit Ethernet, 2 full-size HDMI ports, one port supports 8K60 and the other one only supports 4K60. It has 3 USB 2.0 ports and only one USB 3.0 port. It has a pin header for adding external USB port, and that port is only 2.0. Two MIPI camera connectors. I'll talk more about these camera connectors later in the video, and additional MIPI connector for DSi displays. It has an onboard M.2 connector and a separate connector for eMMC modules. It's available in 4, 8, and 16 gigs of RAM. The 4 gig version retails for $75, 8 gigs for $97, and the 16 gigs for $128. I have to say this board has a ton of features built in and an attractive price point, but we'll see how it fares in our comparison here in a second. And lastly, the Rock 5C. This board is Radxa's direct response to the launch of the Raspberry Pi 5. They even made it comparable with the Raspberry Pi 5 PCIe connector, which was a bold move in my books. It has a Rock chip 3588S2, which is a very similar chip to the one on the Orange Pi board. I did some research and it looks like the S2 version just has fewer I/O features. I'm just going to cover the main specs and point out the differences to the Orange Pi since they're so similar to each other. So it has the same 8-core CPU with 4 fast cores and 4 slow cores, the same GPU and exactly the same AI capabilities. It has Wi-Fi 6 and Bluetooth 5.4, which is an improvement over the Raspberry and the Orange flavors. It only has one HDMI port, it has an extra USB 3.0 port, and it doesn't have a built-in mic that the Orange Pi has, and it only has one camera connector. Okay, I think those are the main differences. The Rock 5C is sold for pretty much the same price as the Raspberry Pi 5, $60 for the 4 gigabytes of RAM version, $80 for 8 gigs, $120 for 16 gigs of RAM, and a whopping $200 for the 32 gigabytes of RAM. And yep, this thing is offered with 32 gigs of RAM. So let's take a look at the first category in my very scientific grading system. For ease of use, I'll take a look at how easy it is to get all 3 boards up and running and the quality of the documentation available for them. Let's start with the company that is synonymous to single board computers, and that is Raspberry Pi. Getting any Raspberry Pi board set up is always a breeze. Pi Imager makes it super easy to select the OS that I want and just burn it to my boot media. I don't even need a second computer to get the Pi 5 set up. With Network Boot, you can just power up the Pi and keep holding the Shift key on the keyboard. This will download an embedded version of Pi Imager to your board where you can select the OS and go through the install process. You can select OSs ranging from retro gaming systems to a general purpose OS like Raspberry Pi OS or Ubuntu. It's all just in Pi Imager. The Raspberry Pi 5 has great tools and awesome documentation with clear step-by-step instructions and screenshots. This is by far one of the tech companies with the best documentation out there. So I'm awarding them 10 points for ease of use. Great start for the red fruit. Moving on to the Orange Pi board. It's nice to see a good variety of images available, including a couple of Android versions. Is this some kind of flex that the main image is based on Arch and not Debian? I can't quite get over the fact that they store the images in the Google Drive, but at the same time, everyone knows how to use Google Drive and it's, easy to use. The guide on how to get started is part of this very long PDF, which is not ideal, but the information is almost all there. I was able to get the board booting from an SD card and from also an eMMC module with no issues at all. Booting from an SSD is not as straightforward though. Since the board has no SPI flash to hold the bootloader information, you have to burn the bootloader image to the SD card. So the OS will live in the NVMe SSD, but you need to keep the SD card plugged in with the bootloader information. It's a little bit clunky, but it works. We already saw that the documentation is available in a long PDF, but let's check out their forum page. Wait a second, what is this? Most of the posts are spam. This is not surprising given that this website doesn't use SSL encryption. I've mentioned this before and I will mention it again. Not having an SSL certificate on your website in today's day and age is just flat out unacceptable. I had a small hunch that all the information is being transmitted in plain text to their servers. So I created a fake account to test it out, and no surprises here, everything in plain text and no encryption. And I don't care how good your hardware is if you're leaving the door open for some browser crypto scam and you can't care less about your users' privacy. I'll carry on with the review on their board, but I'll mark them down for having a borderline useless forum. Given the less than ideal documentation and the hiccups booting from an NVMe SSD, I'm giving them 7 points in this category. I have a few boards from Radxa and I've become very familiar with flashing Radxa OS, aka Debian, to an SD card. I like that after flashing the card, you have the option to change some settings before booting it for the first time, and it's all done in a text file aptly named before.txt. I can create a username with a secure password, configure Wi-Fi credentials, and even choose if services like SSH should be available. Online documentation is seriously lacking for this board. The little documentation that is available on their website is ridden with broken links and typos, which can be very frustrating if you're just getting started in the SBC world. One of the main selling features of the ROC 5C is the PCIe connector, but there is no documentation about it, like none whatsoever. This is baffling to me. With all that being said, they're getting a skimpy score of just 6 points for ease of use. Performance. Let's take a look at performance. Before we get started, I have to mention that both the Raspberry Pi and the Radxa boards have an active cooling system. The cooling in these boards keep them from overheating and throttling the CPU performance during stress tests like the one I'm about to run. Orange Pi, on the other hand, doesn't offer an active cooling system for the Pi 5 Pro, so I had to improvise a little bit with this heatsink I had laying around. I'm trying to keep things fair for all boards, but Orange Pi is making my job harder. The grading here will be pretty simple. I'm going to use Geekbench 6 CPU benchmark, add the single core and the multi-core results, and award 10 points for the best performing board. The other boards will just get a percentage based on their benchmarking scores. The Radxa board gets 10 points in this category for scoring 797 single core and 3098 multi-core. That is a respectable score for an $80 computer, I have to say. In second place, we have the Orange Pi with scores 726 for single core and 2767 for multi-core. This means the Orange Pi 5 Pro gets 9 points. The Raspberry Pi had the best single core score of 822, but lagged quite a bit behind the other boards' multi-core scores, scoring only 1806, so the Raspberry Pi only gets 7 points in this category. The Orange Pi and the Radxa perform better than the Raspberry Pi, even though they don't use that much more power. The power tests were done with a monitor, mouse, and a keyboard plugged in, and of course an NVMe SSD. All three boards have basically the same idle baseline of just 4 to 5 watts. The Raspberry Pi 5 had the lowest power usage under load, with the peak consumption fluctuating around 9 to 10 watts. The Orange Pi board was steady at 10 watts when under load, and surprisingly, the ROC 5C that has the same SoC as the Orange Pi was reaching 12 watts under load. Maybe the fan was making a difference. I don't really know what to think of this. I guess the power consumption matches their CPU performance, so I won't change the performance grading based on power consumption numbers. Desktop performance on all three boards is really good. These are perfectly fine desktop computers. Orange Pi boots super fast when using an eMMC module, and the system is very responsive. I tried out both Arch and Debian images and they both seemed okay. I definitely spent more time using Debian since, who's comfortable with Arch? Orange Pi YouTube playback in 4K is the best one out of the bunch with just a handful of drop frames. I don't have a 4K monitor though, so keep that in mind. The Orange Pi desktop is very similar to the Raspberry Pi desktop experience. The Raspberry Pi 5 is super snappy in desktop mode. I've covered this in other videos, and YouTube playback in 4K on the Raspberry Pi 5 is not great. I doubt most people are buying these computers to watch YouTube on them though. General web browsing on the Raspberry Pi 5 is smooth, and yeah, it's a little bit slower than a regular computer, but it's very passable. Again, these things are $80 after all. The desktop experience on the Radxa is also really good. Everything feels responsive, and the desktop environment has a more modern feel than the Orange Pi and the Raspberry Pi. Web browsing, on the other hand, is a little buggy. Chromium crashed multiple times on me, which is not something that happened on the other boards. Web browsing is a very basic task a computer has to be able to do nowadays, and the Radxa board leaves a lot to be desired. I'll duck 1 point from the Rock 5C for the less than stellar web browsing experience, so 9 points it is for performance. Things are pretty tight on the scoreboard with Raspberry Pi leading by a thin margin. Radxa is behind, but does it have the AI features and other capabilities to win the race? We'll find out. So moving on to the next category, features and expandability, aka support. These boards are all very similar if you're using them as a standalone computer, but it's a very different story if you're planning on attaching additional hardware to these things. For starters, the Raspberry Pi 5 and the Rock 5C both have the same PCIe connector. There are quite a few adapter boards in the market right now that can add things like 2.5 gigabit networking, dual NVMe drives, or even 5G networking. Although most of the boards are designed for the Raspberry Pi, I've tested a few of them with the Rock 5C and they work just fine. I suspect that the boards that depend on specific firmware like the AI accelerator HATs might not work out of the box on the Rock 5C, but more on AI capabilities later in the video. The Orange Pi 5 has an M.2 connector on board, and you don't need an external HAT to connect a full-size NVMe drive to it. This means that I don't have to spend the extra $20 for NVMe adapter board, and $20 is not nothing. Speaking of differences between the Orange Pi and the other two boards, the Orange Pi is the only one that doesn't have the standard camera connectors that we usually see on most SBCs. Instead, the Orange Pi 5 requires this camera adapter board that seems way too bulky when compared to what Raspberry Pi and Radxa have to offer. While you can buy cables of varying lengths for the Raspberry Pi and the Radxa boards, you are stuck with what Orange Pi has to offer, which, according to the webpage, is just this one length. Both the Raspberry Pi and the Rock 5C have a compatible active cooling solution that, like I have mentioned, but I couldn't find one for the Orange Pi 5 Pro. The Orange Pi has a 5 volts fan header, and the accessory section of the documentation mentions that you can control the speed of the fan with PWM, but there is no mention of which heatsink and fan will work with the Orange Pi 5 Pro. So, score-wise, the Raspberry Pi 5 gets a 10 for having a vast ecosystem with large companies making hats and accessories for pretty much anything you want to attach to your Pi 5. The Rock 5C gets an 8. I appreciate that Radxa made a board with the same PCIe connector as the Raspberry Pi 5, and they're trying to take advantage of the existing Raspberry Pi ecosystem, but the number of compatible hardware for the Rock 5C is nowhere near what is available for the Raspberry Pi board. The Orange Pi 5 Pro gets a low 4 on this one. for having limited first-party hardware available, and for making design decisions that make it almost impossible to use third-party accessories. Sorry, it's harsh, but it is what it is. Let's talk about everyone's favorite topic nowadays, AI. While both the Orange Pi 5 Pro and the Rock 5C come with an embedded neural processing unit, or NPU, the Pi 5 requires a separate AI kit that costs $70. NPU is the part of the processor that can accelerate AI tasks. There are two main use cases for AI acceleration on these boards. Computer vision, where the computer can identify objects in an image, and large language models, LLMs, like a chatbot or a code assistant. I went on a side quest to test the AI capabilities of these boards, and let me tell you, it was quite a quest. Since the Orange Pi and the Radxa boards have the exact same NPU, I figured I would start with them first. My goal for this test was to set up a local coding assistant that can help me out with my Python scripts. With some fiddling, I was able to convert the models to the correct format using an x86 machine running Ubuntu. If you're just a beginner starting with Linux, you might have a hard time following the steps to get things converted correctly. To run these LLMs on the Rock chip boards, you need NPU driver version 0.9.6 or higher, but the images available from Orange Pi and Radxa had an older firmware. Orange Pi went as far as saying their OS images should be version 1.0.4, but this version was not available from, their Google Drive. I hit them up on Twitter because, remember, the forums are useless. They did make their OS available for download a week or so later, so yay? Anyway, while going down the Rock chip LLM rabbit hole, I discovered the Rock chip images made available by Joshua Reek. Joshua has Ubuntu images tailored for a ton of Rock chip boards, including the Orange Pi 5 Pro and the Rock 5C. And guess what? His images have the most current NPU firmware. It's kind of crazy that the community OS has better support than the manufacturer's OS. It's good to see Rock chip community growing though, so watch out, Raspberry Pi. I was pretty underwhelmed testing some of the smaller models like Tiny Llama. It was not helpful with coding tasks at all. But then I tried the Phi 3 Microsoft model focused on coding tasks. And hey, would you look at that? It's pretty handy with some Python coding. Speed is okay. It seems a little slow when compared to tools like ChatGPT, but I'm okay with compromising a little bit of speed to have a fully local and private chatbot. I was feeling pretty accomplished, so I moved on to working with LLMs on the Raspberry Pi 5, keeping in mind that the Pi 5 doesn't have a built-in NPU. You might be thinking, well, you can plug in one of the AI kits the Raspberry Pi offers and everything is going to work just as well as the boards with the RK3588 chip, right? Unfortunately, the Halo accelerator that comes with the Raspberry Pi AI kit is not designed to work with LLMs. It's only useful for things like computer vision. So in this test, we'll be relying on CPU processing on the Raspberry Pi 5 alone. Olama has an install script that worked right out of the box on the Pi 5. No need to convert models before using them like I had to do for the other two boards. I don't have a way of measuring tokens per second, but this feels pretty slow. The fan on the Raspberry Pi 5 was running full tilt while responding to my prompt. So I don't know, LLMs are easier to set up on the Pi 5, but it's much slower and just not as useful. Just to make sure I was keeping things fair and consistent, I went back and I ran the same prompt on both the Raspberry Pi 5 and the Rock 5C. As you can see, the Pi 5 takes a little while to get started responding, and once he did, it was still slower than the Rock 5C. Which makes sense because it's using CPU only. One thing with these AI chatbots is that even though you're running the same model, you won't get the same responses every time. The local LLM of the Rock 5C was wordier than the Pi 5 and is still finished first. And by the way, if you're still watching this video, thank you. I really appreciate it. If you're going to leave a comment, make sure to mention I love Pi. That way I know you're one of the few people that watch most of the video. So what's the AI score? I'm giving the Orange Pi and the Radxa 8 points because of the whole issue with images not having the correct NPU firmware. The Raspberry Pi 5 only gets 4 points since it's half as useful. I'm not going to test computer vision because I don't have the Raspberry Pi AI kits yet, so I'll save this comparison for a future video, so stay tuned. Alright, enough of this AI shenanigans, let's take a look at the final score. The Raspberry Pi 5 and the Radxa Rock 5C tied with 31 points, and the Orange Pi 5 Pro scored the lowest with 28 points. But you can see they have different strengths and weaknesses. The Raspberry Pi is easy to set up and easy to use. It has great first-party and third-party hardware support, but it lacks in other areas like performance and AI capabilities out of the box. The Rock 5C is basically the inverted mirror image of the Raspberry Pi. It has a great performance and it does well when it comes to AI, but it completely lacks in documentation. The Orange Pi also has great performance, but it lags behind quite a bit in hardware support. So hopefully this makes it a little bit easier for you to choose your next single board computer. Did I miss any features you would like to see covered in a future video? Let me know in the comments and I'll try to get it tested for you. And with that, I'll see you in the next one.